How come it's not screen free? I think I got down to 16, so anyways, I'll start with that. Yeah, use Mr. C with just lowercase, no dot. Okay. Did I do 15 yet? Can't remember with your class. I don't think I got as far as you guys. I know I did 13, 14, right? I think I did. So I'll go to 15 then. Start at 15. So read it over to yourself. Okay, you guys didn't even do 13. Okay, I'll start from the beginning. Not going to hurt. 13. Sorry for that. A little confusing. The other classes ahead. Okay, 13. Using the diagram, find the sprinter's velocity at 2 seconds. So I'll draw it for you. So what's important is this is a position time graph. When it says find the speed at 2 seconds, the speed is constant if it's a straight line. This is constant speed. What does that mean, constant speed? Yeah, so it's the same speed. Every second. Same speed at 1 second, same speed at 2 seconds, same speed at 3 seconds. Doesn't change. So how do you find that speed? If it's a straight line, you just calculate the slope. So the slope is the speed at 2 seconds or any other second. So we're given the rise. They actually give it to you at 17.8 minus 10, or 7.8. And then they give you the run, 2.4 minus 1.62. That's 0.78. So that gives you 10 meters per second. $14. It says use your hand. I'm just going to express it. I'll tell you what is going on here. So if you look at 16A, I'll draw it out for you. That's A. B. And then C is parallel to B. That's a key point. So remember, this is a D versus T. It's not a V versus T. So when you have a horizontal line and a D versus T, it means something different than when it's on a V versus T. On a position time graph, on this type of graph, means horizontal line means the slope is 0. Okay. What does the slope represent on a position time graph? Okay, I know you know it. Let's see if someone else gets it. What is the slope on a position, not a velocity, but position? Yeah. Yeah, it's the velocity. So if the slope is 0, the velocity is 0. On this type of graph, D versus T. Okay. You could just say velocity 0, or you could say at rest. Either one for A. For B, well, if it's leaning upwards, it's a positive constant velocity. Okay, that's for B. I mentioned earlier that C is parallel, like railroad tracks, which means the slope is the same. So it's the same velocity. What's the difference? C is starting ahead. I'm just going to give you a number. I'm making it up. Starting at 5 for C compared to, let's say, 0 for B. C is starting ahead of B by 5 meters, or whatever the number is. But it's moving at the same speed. Okay, 15. Just look over the graph, A, B, and C. Just take a look at that question. I'll draw the graph for you here. Okay, notice something here with this graph. You're no longer plotting D. This is V versus T. Okay. So what does it mean to say it's V versus T? It means you're now at each second. So let's say I'm making these numbers up. Let's say that's 1 second. At the 1 second mark, you can directly read what the velocity is off the graph. So I'm making these numbers up. Let's say this is 10. 10 what? 10 meters per second. So you no longer have to, in this case here, for a position time graph, you need to calculate the slope. You need to actually do a calculation to find what the speed is. Guys at the back, you better be watching my lesson. You're giggling, which means I'm either making some mistake or you're watching a cartoon or something. I'm telling you, if I catch you, it's not going to be pleasant. Okay, so that's the difference. You can read directly off the graph. You don't have to calculate the slope. So I'm just, again, making these numbers up. Let's say at the 2 second mark, which is that little point on the line, That corresponds to, let's say, 20. Corresponds to, again, I'm just making these numbers up, but the point is that for each second, 1 second and then 2 seconds, you can read the corresponding velocity directly. Anything else different about this graph? Yeah, the units. Look at the units here. Units are meters per second for this graph, and for this graph, the units meters. Entirely different. Okay. So it says, I just made these numbers up. I'm going to read directly off the graph that I see here. So in 15A at 0, I'll redraw it. I'll do it properly. I'll do that for you. Trying to gauge this. 1 is 20. Okay, so the line looks like this. So first of all, at the 0 second mark, at this point here, you're moving at 10. 10 what? Well, the unit is meters per second. So you're moving at 10 meters per second to start with. This is 15A and B and C. That's referring to the middle graph. If you look down on the handout here, it's in the middle. Referring to that graph there. Okay, at 1 second, corresponds to this dot here, which corresponds to a velocity of 20. This is all rough, right? You're not going to get the exact value. I take that into account. And at the 2 second mark, you're moving at 30 meters per second. Okay, so what's happening to your velocity? 1 second. What's happening to your velocity? Yeah, so your velocity increases. Velocity increases. Yeah, Toby? Yeah, it's going to be, like I said, I take into account, you could see the drawing. I mean, I looked at it from like a skewed angle here, so it's going to be approximately 10, approximately 20, yeah. I take that into account. Not very accurate. $16. So I already answered it for you. You just said what happens. It says, question is, what's happening to the instantaneous velocity? You just said it. It increases. So the speed of the velocity increases. Okay, 17. Says sketch velocity time graph. So let's draw the first graph. This is what we're going to start with. Okay, so how does that translate to a velocity time graph? Right, this is D versus T. This is V versus T. Okay, let's just analyze each green line one at a time. So A, you go back to here, go back to what we said earlier. It's the same diagram that we started with. Where is it? Right here. I said that A represents slope of 0. So you're at rest. Slope of 0. You're not moving. Another way of saying that is the velocity is 0. So how do you represent velocity being 0 on a velocity time graph? It's just a horizontal line starting at 0. At the 1 second mark, it's 0. At the 2 second mark, 0. 3 second mark, 0. 0 throughout. Make this a little thicker. Zero at each point in time. Okay? And then B and C, go back to what we said earlier because it's the same graph. We said B and C are both constant velocity. Okay? So these two, constant velocity. Now, what is the velocity? I don't know what the velocity is. I'll make up a number. Let's say, again, it's 10 meters per second. How does that translate to the velocity time graph? Well, the key word is constant, not changing. I'm going to just write down 10 here. 10 what? Meters per second. That's the unit. So if it's a constant 10, that means it doesn't change. At 1 second, it's 10. At 2 seconds, it's 10. 3 seconds, it's 10, etc. It's another horizontal line. For A and B, because they're parallel to each other in this diagram, right? Did I say A and B? I meant C or B and C. Be clear. This is A here. Come on. That's A there, and this is B and C. So why does that one line represent B and C? Because if you go back to the position time graph, they're parallel. They look like railroad tracks. Same slope. Okay, 18. Okay, that one's a little more complicated. Read it over to yourself quietly, and then I'll show you how to do it. In fact, you know what? Now that I'm going to go over with you in a second, but now that we've covered what you need to know, let's see if you haven't done it, give it a try. I'll give you a minute, couple minutes. See if you can do 8B or ABC. If you can do it. Yeah. Yeah, I'll show you how to draw it. It might be It's a little unfair because we haven't talked about it, but in math, if you've got negative numbers, then it drops below the x-axis. I just want to highlight the importance of constant velocity is represented by a horizontal line. Okay. So I'll do the first part. I'll get you started. Here's the hint. You're going to need a graph that looks like this, where the origin is here, your x-axis is here. This now becomes time. And pay attention, it says here this is a velocity that's moving at. So we're going to make it a velocity time graph, not a position time graph. It's easier to draw constant speed with a velocity time graph. Yeah. Oh, did it say kilometers per hour? Thank you. Yeah, let's stick with kilometers per hour. Normally it's meters per second, but good point. Kilometers per hour. So this is hours. Okay. So the reason why I had to draw the graph here is because you're dealing with, first of all, positive 75 kilometers per hour. On the way there, you go for a couple hours at 75 kilometers per hour, and then you stop for a couple hours, and then you reverse direction. If you read it, it says it reverses. And reversing direction means you go from heading east, which is positive, to heading west, which is negative. So the reason why I had you draw the graph like this is because you have to also indicate negative velocities as well. So let's do that. So let's just number this. This will be positive 75. And again, it's kilometers per hour. And then down here, this will be negative. Okay, and then I need to number the hours here. We have 4 hours to begin with. So. You need a total of 9 hours. The first 4 hours, it's going at 75. And it's moving, we're told, at a constant 75. And that's why we're using this velocity time graph. It's easy to depict constant speed, horizontal line, at positive 75. Okay, now normally in between, you're told that you rest between 4 and 6 hours. I'm going to make this green. It's going to be easier to see. Come on, straighten out. So make it green so it's easier to see. In between 4 and 6, you're sitting at 0 because you're at rest. Now in between here, yes, you're going to slow down, but I'm not worried about that. We'll just draw a little vertical drop. I know it's not a vertical drop, but we'll just approximate it. So yes, you slow down to 0, but don't worry about that for now. And then after hour 6, you start moving again, but in the opposite direction, indicated by a negative. And you move for 3 hours instead of 4. So you move from 6 to 9. So we'll call this, you've got 2 different areas. This is going to come into play in a second here. You got D1 and you've got area D2. Okay? So that we'll come back to. It says in B, find the area under the curve for the first 4 hours. So in other words, find D1. D1 is the area. Area is just base times height. Okay, or height times base. Doesn't matter the order. There's a reason why I'm going to do that. Okay, we'll come back to height times base in a second. What are the numbers? The height is 75. I'm going to put the units in red so you can see how they cancel out. The base is 4. Whoop, not kilometers per hour, just hours. Okay, so this is 300. The hours will cancel out. That's the point of putting a different color to show you that the units are important to keep track of if you're unsure. So it works out as we expect. The unit should be the unit for displacement, which in this case is kilometers. We start with kilometers per hour. Displacement should be in kilometers. Plus, got to be positive, because each of these numbers is positive. Time is always positive. In this case, the velocity is positive. We need to keep track of this. Okay, so that's our D1. C, just read that over to yourself. That's the complicated part. Okay, so in C, they're asking you for how to use the graph to find the distance from the starting point. So with any velocity time graph, the area will give you the area. We've got to be more precise now. This is exactly what the area gives you. It gives you the displacement. It's not just the distance. We go one piece of information further. Displacement means you've got a direction as well as a distance. So it's not just how far did you travel, which direction as well. Because if it's a negative direction, that means you're going to have to subtract it. This is a negative displacement. We'll calculate it. We'll see what it is in a second. This is a negative displacement. Why? Because this is negative. Okay? So D1, we already calculated. We said D1 is positive 300 kilometers. What about D2? Well, D2, go back here. D2 is just the area, the green area that I shaded there, which is what? Height times base. What's the height? The height now is negative 75, not positive. Height times base. What's the base? The base is now 3, not 4, which is 225 kilometers. And it's negative. Okay. How do you find the distance? The total distance. Whoa. Equals the displacement, the total displacement. That's how you use the graph. How far? The question is, what does the, okay, the question is, how do you find the distance the car is from the starting point? That is what the value of the displacement is. The value of the displacement is how far the car is from the starting point. So that's why we're able to equate them. Distance from, we'll add this so it's clear, starting point. They're one and the same thing as far as value. Okay, so what does that mean? Just add these two together. Add the two displacements together. What does this mean? It means that you end up east of where you started. Positive. So it's east. Okay, now does that make sense? Yeah, physically it does. Let's just take a look at a number line. You move this way. Does adding up those areas actually give us the distance you are from the starting point? Well, let's think about it. In the first 4 hours, you moved this way, 300 kilometers. Then you came to a stop. Then you turned around and you headed back. How far back did you head? 225. So what are you left with? Whatever this is, the difference between the two, which is 75. So it does make sense. The quick way is just find the areas. Make sure you treat anything below the graph as negative, so it's subtracted. That gives you the total distance from the starting point. That's what displacement is. How far are you from the starting point? If it's a positive, if the overall value is positive, like it is here, you're east of it. If it was negative, you'd be west of it. Okay? Okay. In class, this is going to help you with the test. Make sure you go over what we just did. I'm not going to put a question like 18 on the test, but definitely, what is it, 15 to 17, those are possibilities. So I want you to do on page 58. If you turn to page 58 in the handout. Under applying concepts. Yeah, sure. Under applying concepts, you can do 6 to 11. That includes page 59 as well. You getting it? So it's this part here where it says applying concepts. Those questions. I'll post this for you. Yep, go ahead.